This is not every step at all. But in the first phase of glucose, in fact, the first 5 steps in glucose, whatever, it takes about 5 steps to get from glucose to PGAL stands for phosphoglyceraldehyde. It's just a 3-carbon sugar. Don't worry about it. There is actually an energy the point of this is to show you that there is an energy investment phase to glycolysis. It is not the exact same as, but it's analogous to activation energy, right? You know, even if something is overly exergonic, sometimes you got to put some energy into it to make it want to happen. And that's what we're doing here. We're adding some energy to this to make it less stable. The more energy you add to something, the less stable it gets. And guess what? We want it to split in half, right? So we got to pump up some energy to make it want to fall apart. So that's what we're doing, is making it less stable. The very, this doesn't show the first step. You'll see that 2 things happen right here, right? We're converting glucose into what? Fructose. Same carbon, still C6H12O6, C6H12O6. This was an aldehyde, this is a ketone. You probably don't care about that. This forms a 6-sided ring. This forms a 5-sided ring. You probably don't care about that, except you'll see in a minute that if you take something that is a pentagon in shape, it's easier to bisect into 2 things that are similar than it is something with 6 carbons. I'll show you that in a minute. So there's 5 steps here. There's an energy investment phase. Then there's an energy releasing phase. So this is the endergonic part of glycolysis. It's the first 5 reactions or so. And then there's an exergonic part of glycolysis. It's the last 5 reactions or so. Once we split this 6-carbon thing, that's where we start releasing a bunch of energy. And we release energy that drives the synthesis of ATP. So we're going to actually get 4 ATP out, but we invested 2, so our net ATP production is 2. There. And there must be 2 places, well, 1 place, but because this happens twice, where there is an oxidation of the substrate. So we're oxidizing this food, this carbon-containing compound here. So if you have an oxidation, you also have to have a reduction. And there's our 2-NADH. All right.